Speed Maths 5. Average Tricks. The topic that we are looking at today is averages. The average, or mean, of a set of observations is calculated by adding all the observations together and then dividing that sum by the total number of observations. The first model of average calculation is consecutive numbers. Consecutive numbers are numbers that follow each other in order without gaps. For example, 1, 2, 3, 4, 5 are consecutive numbers. Let's look at some examples to understand the average of consecutive numbers. Find the average of given numbers. To find the average of the set of numbers 96, 97, 98, 99, 100, you need to add all the numbers together and then divide that sum by the total number of numbers. But there is a really interesting math trick behind it. For a set of consecutive numbers, the middle number is always the average, also known as the mean of the set. So, you don't waste your time finding the average formula and substituting the values in a second. As you see the question, just write the middle number as the answer. Here, the middle number of the given even number is 98, which is the average of given consecutive numbers. It's important to note that this applies only to consecutive numbers, and not to any set of numbers. Now, let us find the average of the given consecutive numbers 101, 102, 103, 104. Since the set of numbers you provided has 4 numbers, which is even, there are 2 middle numbers, which are 102 and 103. The average of these 2 numbers is 102.5. So, the middle number of the set of consecutive number is 102.5. Similarly, let us find the average of the given consecutive odd numbers 27, 29, 31, 33. By seeing this, it is always known that the middle number is the average value. Here, the middle number is 30, which is the average of given odd numbers. The middle value among given consecutive even numbers 52, 54, 56, 58 is 55, which is the average value. Let's look at some more examples to better comprehend this average concept. A, B, C, and D are 4 consecutive odd numbers and their average is 42. Find the smallest number, the largest number, and the product of B and D according to the concept of averages. The middle number is the average number. So, the average of 4 consecutive odd numbers is 42, which means the middle number is 42. Since it is an even number, the 4 consecutive numbers are shared on both sides. Then, the consecutive numbers are as follows: 39, 41, 43, 45. Thus, the smallest number of 4 consecutive odd numbers is 39, the largest number is 45, and the product of B and D is 41 into 45, which is equal to 1845. It is noted that the average of any number series or group is always between its smallest and largest value. Let us look at another example in consecutive numbers. The average of 54 consecutive even numbers is 93. Find the smallest number and the largest number. It is easy to find the largest and smallest value for given consecutive numbers using the number of gaps among numbers. The first number in the set is the smallest number. The last number in the set is the largest number. The number of gaps is determined by subtracting 1 from the number of terms in the set. The total number of consecutive Even numbers in this given problem is 54. The number of gaps will be 53. The smallest number will be 93 minus 53, which is 40, and the largest number will be 93 plus 53 equals 146. Let us now learn the second model for solving averages problems. Let's look at one example to understand the average concept in terms of with non-consecutive numbers concept. The average of 57, 49, 53, y, 62 is 56. Then find why. There is a really interesting math trick behind it. To find the deviation of each value from the average value, you would subtract the average value from each individual value. For example, for the first value of 57, the deviation would be 57 minus 56 is equal to 1. For the second value of 49, the deviation would be 49 minus 56 equals minus 7. You would repeat this process for all the values given 53, y, 62. The sum of the deviations of a set of values is always 0. Then, the equation becomes y equals to 56 plus 3, which is 59. The third model for solving average problems is to use the basic average formula. The basic concept of finding the average of a set of numbers is to add all the observations together and divide by the total number of observations. The formula you provided expresses this concept mathematically. AVG is equal to the sum of all observations divided by the total number of observations. Let's look at an example to understand the basic concept of averages. The average age of A, B, and C is 26 years. If the average age of A and C is 29 years, what is the age of B in years? We can use the information provided to set up an equation to find the age of B. Since the average age of A, B, and C is 26 years, we know that age of A plus age of B plus age of C divided by 3 is equal to 26. Also, the average age of A and C is 29 years, we know that age of A plus age of C divided by 2 is 29. We can use these two equations to find the age of B. First, we'll substitute the second equation into the first equation for finding the age of B. Age of B equals 78 minus 58, which is 20. So, the age of B is 20 years. Here is an example to help you understand the basic concept of averages. The average age of 7 numbers is 5. If the average of the first 6 these is 4, what is the 7th number? We can use the information provided to set up an equation to find the 7th number. Since the average of 7 numbers is 5, now, we can find the sum of the 7 numbers is 7 into 5, which is equal to 35. Also, the average of the first 6 numbers is 4. We know that we can find the sum of the first 6 numbers is 6 into 4, which is equal to 24. Now we can subtract the sum of the first 6 numbers from the sum of all 7 numbers to find the 7th number. 35 minus 24 equals 11. So, the 7th number is 11. Let's look at the third example to understand the basic concept of averages. The average of 11 observations is 50. If the average of the first 5 observations is 47, and that of last 5 observations is 52, then find the 6th number. We can use the information provided to set up an equation to find the 6th number. We can find the sum of the 11 observations is 11 into 50, which is equal to 550. Now, we can find the sum of the first 5 observations is 5 into 47, which is equal to 235. Also, we can find the sum of the last 5 observations is 5 into 52, which is equal to 260. Finally, we can subtract the sum of the first and last 5 observations from the sum of all 7 numbers to find the sixth number. 550 minus 235 plus 260 equals 55. So, the sixth number is 55. Let's look at the fourth example to understand the basic concept of averages. The average age of 10 numbers is 7. What will be the new average, if each of the numbers is multiplied by 8? If each of the numbers in the set of 10 is multiplied by 8, then the new average of the set will also be multiplied by 8. So, the new average will be 7 into 8 is equal to 56. Model 4, or the equation concept, is a way of solving average problems by setting up and solving equations. This method involves using the information given in the problem to set up equations and then using algebraic techniques to find the unknown values. Here is an example. The average salary of all the staff in an office of a corporate house is Rs 5,000. The average salary of the officers is Rs 14,000 and that of the rest is Rs 4,000. If the total number of staff is 500, the number of officers is. We can use the equation concept to solve this problem. Let x be the number of officers. Then, we know that the total number of officers is 500, and the number of non-officers, also known as the rest of the staff, is 500 minus x. We also know that the average salary of all the staff is Rs 5,000, the average salary of the officers is 14,000 rupees and that of the rest is Rs 4,000. We can use this information to set up equation 500 into 5,000 equal x into 14,000 plus 500 minus x into 4,000. We can now solve for x by simplifying the equations. So the number of officers is 50. We can solve this type of question in a smart way using the proportion technique. We also know that the average salary of all the staff is Rs 5,000, the average salary of the officers is Rs 14,000, and that of the rest is Rs 4,000. The difference between 5,000 and 4,000 is 1,000. Similarly, the difference between 14,000 and 5,000 is 9,000. It means that the ratio of the number of officers to the rest of the staff is 1 to 9. 1 plus 9 equals 10. Total value 10 is 500 staffs. Then, 1 value is 50. So, the number of officers is 50, and the number of the rest of the staff is 500 minus 50 equals 450. The fifth model of average calculation is a true or false concept. Let's look at an example in the average concept of true or false. The mean of marks scored by 100 students was found to be 40. Later on, it was discovered that a score of 53 was misread as 83. Find the correct mean. To find the correct mean, we need to adjust for the mistake in the score of 53 that was misread as 83. First, we'll find the total of all the scores before the correction. The total score is 40 into 100, which is 4,000. Next, we'll subtract the incorrect score of 83 from the total and Add the correct score of 53 to 4000 minus 83 plus 53 equals 3970. Finally, we'll divide that number by the number of students to find the new mean. 3970 divided by 100 becomes 39.7. So, the correct average is 39.7. In Model 6, the concept of including or excluding certain observations or data points is often used when calculating averages. Let's look at some examples of this average concept. The mean weight of a class of 35 students is 45 kg. If the weight of the teacher is included, the mean weight increases by 500 grams. Find the weight of the teacher. There is a really interesting math trick behind it. For including or excluding concepts, we use direct formula, that is, the average value plus or minus the change in value into new count is equal to the new person's value. Given that the mean weight of the class of 35 students is 45 kg, we know that if the weight of the teacher is included, the mean weight increases by 0.5 kg. Now, we can use this new mean to find the sum of weights including the teacher, that is 36. We can write 45 plus 0.5 into 36 so the weight of the teacher is 63 kg. Let's take another example to better comprehend this concept. The average weight of a group of 9 students is 43 kg. When a new student joins the group, the average weight of the group becomes 45 kg. What is the weight, in kilogram, of the new student? Simply, we can write 43 plus 2 into 10 is equal to 63. So, the weight of the new student is 63 kg. Let's look at the third example. The average mark of a group of 19 students is 76. When the mark of one student is excluded, then the average is decreased by 2. Calculate the mark of the student. Given that the average mark of the group of 19 students is 76, we know that if the mark of one student is excluded, the average is decreased by 2. Now, we can use this new average to find the mark of the student, which is 18. We can write 76 minus 2 into 18 is equal to 40. So, the mark of the student is 40. Fourth example. The average weight of M boys is 43 kilograms. If the weight of their teacher, who weighs 63 kilograms, is also included, then the average becomes 45 kilogram. Find the value of M. Given that the average weight of M boys is 43 kilogram, we know that if the weight of teacher is included, the average is increased by 2. Now, we can use this new count to find the value of M, which is M plus 1. We can write 43 plus 2 into M plus 1 is equal to 63. Solving this equation for finding M is 9. Let's look at the fifth example. The batting average of Sachin in 15 innings is 55. The difference between the runs of his best and worst innings is 65. Excluding the best and the worst innings, the average of 13 innings played by Sachin is 50. Calculate Sachin's best score. To calculate Sachin's best score, we can use the information given in the problem to set up and solve a system of equations. We'll call Sachin's best score B, and his worst score W. From the problem, we know the batting average of Sachin in 15 innings is 55. So, the total number of runs he scored in 15 innings is 15 into 55 equals 825. Excluding the best and the worst innings, the average of 13 innings played by Sachin is 50. So, the total number of runs he scored in those 13 innings is 13 into 50 equals 650. The difference between the runs, that is, 825 minus 650, becomes 175, which the best and the worst score of 2 innings. So, B plus W equals 175. From the problem, we know the difference between the runs of his best and worst innings is 65. So, B minus W equals 65. Solving these equations to find the best score. Simply add these equations together. We get 2B equals 240. Then Sachin's best score is 120. Model 7. Replacement concept. The replacement concept in averages refers to the idea that when a player is replaced in a team, the statistics of the team should be recalculated as if the replacement player had been on the team the entire time. This concept is often used in baseball and cricket to better compare the performance of teams or players. Let's look at some examples to understand this concept. The average weight of 10 members in a family decreases by 2.5 kilograms when a new member comes in place of one of them weighing 70 kilograms. Find the weight of the new member. Simply, we can write 70 minus 2.5 into 10 is equal to 45. So, the weight of the new member is 45 kilograms. The average age of 8 men is increased by 2 years, when 2 of them whose ages 21 and 23 years replaced by 2 new men. The average age of the 2 new men is, simply, we can write, half of 44 plus 2 into 8 is equal to 30. So, the average age of the 2 new men is 30. The 8th model is average speed concept. The average speed concept refers to the measure of how fast an object or a person is moving over a certain distance or time period. It is calculated by dividing the total distance traveled by the total time taken to travel that distance. The unit of average speed is miles per hour or kilometers per hour. Let's look at an example in the average speed concept. A person covers 9 kilometers at a speed of 3 kilometers per hour, 25 kilometers at a speed of 5 kilometers per hour, 30 kilometers at a speed of 10 kilometers per hour. Find the average speed of the entire journey. To find the average speed of the entire journey, you need to know the total distance traveled and the total time it took to travel that distance. Distance traveled is equal to 9 kilometers plus 25 kilometers plus 30 kilometers is equal to 64 kilometers. To find the total time, you need to know the time taken for each segment of the journey and add them together. Time taken for first segment is equal to 9 kilometers per hour by 3 kilometers per hour is equal to 3 hours. Similarly, time taken for the second segment is 25 by 5 equals 5 hours. Time taken for the third segment is 30 by 10 equals 3 hours. Then the total time becomes 3 plus 5 plus 3 equals 11 hours. Now that you know the total distance traveled and the total time, you can calculate the average speed. Average speed is equal to 64 kilometers by 11 hours or 59 by 11 or approximately 5.82 kilometers per hour. Let's look at the second example.